Let us practice together on how you can describe the shadings here. Yeah, so in the previous lesson, we talked about the basics about shading under set theory, and here we're going to practice on more examples, so we can start. So this is just a quick recap of what we did last time, how you would describe the shadings. So check out for the separate video just for you to have a start. So now let's have some examples. Okay, so we start with something very interesting. We have been told that in each of the Venn diagrams in this figure, shade each one of the following separately. So this was a lot of work. Yeah, so meaning you shade x minus y in here, you also shade in here. So these are questions from the tutorial sheet, so they are just for you to practice. So we're going to go through all these. So we start with this one. How would you shade x slash y? So remember, x slash y simply means x minus y, and this means that you are going to shade the things which are in A. You shade the things which are in A. These are the things which are in A, but you can see we are not crossing to go into Y because we are saying minus Y, meaning do not touch set Y. So this is the shading for X slash Y. You just shade what is in X, but do not shade what is in Y. Yeah, and then on this other diagram, again you shade what is in X. So this is in X, this is in X, 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 X. So we can penetrate, we don't cross here because this we're now entering Y, so do not enter Y. So meaning we have shaded X slash Y. Yeah, so it's very easy, almost no thinking. So just a quick one. What if they say X slash, what if they say Y slash X? What would you do? So pause the video and then try to solve in your book quickly. So if you did this, then you are right. So this is the shading for Y slash X, simply meaning you shade what is in Y, and then X you do not shade it. We do not touch what is in X. Also here we shade what is in Y, so all this is in Y. Now all this, so but at this point we do not cross because we do not want to enter X. Yeah, so this is how you shade. So we're done with the baby example. Let's go to the next one. So Y slash X slash Y union Z. So this simply means that we're going to shade what is in X, but whatever is in Y and Z, do not touch it. Don't even think about it unless so what is in X we shade, just like a grade 2. You see that shading is very important. So we've shaded what is in X. This is X, so we do not cross this area because this is Z. We do not want to touch Z, and we also do not want to touch anything in Y. Yeah, so this is the shading. And then here again we shade the same X. This is the thing in X, and then you do not cross. We do not want to shade Y, we do not want to shade Z, so we end there. Yeah, so you see how quickly we are moving. So me, I'm explaining and we have answered this under 5 minutes. So imagine if we're not even explaining, you can solve it in like a minute. So let's go through this now. We have x intersection y intersection z. Okay, so for this one, kutekanya, meaning is to be patient, don't rush. So let us shade x complement. X complement simply means the things which are outside of x. So these things which are outside of x, we shade them. So this is outside of x. So everything which is outside of x, we shade it. So this means that we have shaded x complement. Up to this point, I know we're together. And then let us shade y intersection z. Y intersection z, it is in here. This is y intersection z, where y and z are meeting. So to know the final answer, remember intersection means what are the common things in x complement and in this y intersection z. So the intersection simply means where we have two colors. So outside here you can see we have black only. So this is not the intersection. So this is not the intersection. This is not the intersection. So in here we do not have red, meaning this is not the intersection. So the intersection is just there where we have both red and black. So this is your final answer. So this is how you would shade. Okay, so I hope you've gotten that. So we'll just quickly go through it together here. For the sake of myself, I want to be very sure that at least you get what I'm saying here. Y intersection z. So what you basically do, so meaning the answer, it is here like this, although the diagrams are different. So I was trying to demonstrate clearly. So like in shading in your book, this is the answer. Yeah. So we can progress. So let's go to the next one. So still on this one. So remember, this is a tutorial sheet. In an exam, you just be asked, maybe usually it can just be a multiple choice, like they give you a shading, they'll shading here, and then they start giving you options like, what shading is this? A, is this x minus y intersection z? Is this x complement intersection y intersection z? These two are different. So this is how multiple choice questions come. So for you to know which one is the answer between this and this, you have to start shading them one by one. You shade this, you see if you're going to get that. You also try the other one. Yeah. So let's quickly shade this in here. X complement, what's outside of x is that. So this is what is outside of x. So this is our x outside of x. So you can see inside of x we do not shade. And then let us shade y intersection z. So this is y, this is z. So the intersection where y and z are meeting, it is in here. This is the intersection where y and z are meeting. So for you now to know the final answer, you just shake where you have two different colors. So if you are writing maybe in a test, and you can just use maybe a pen and a pencil. So this is the final answer. This is the intersection. So this is the intersection for x complement, intersection y, intersection z. Yeah, so I'm even getting tired. So let's go to the fourth one. This one, so the first thing here, you can just simplify. So you have two options, like you shed this or you simplify. So the first kind of simplification here is this. So here you have x intersection. So you know the complement, this one, it can multiply. So we're going to have y complement union, complement times intersection is union, z there. So complement and complement, it cancels. So then what you need to do is to shed this. Yeah, so this is the first kind of simplifying that you can do. And then there's also another kind of simplification. This one comes when you practice a lot. So if you have x, so on this one, in case it's not so clear, x intersection y, z complement. So for this one, you like I explained previously, when you see, for example, a minus b, you know this simply means a slash b, and a slash b simply means you write a, this slash, which is also the minus, it can change, it becomes intersection, and then immediately it becomes intersection, then you see this b is going to have a complement. Yeah, so this is just one thing you have to know. So like, for example, you have y minus z. So this simply means y, the intersection, the minus, it will be intersection, and then z should have a complement. And this is what we have there. So this simply means we have x intersection. So in here, this simply means y minus z. Yeah, and then complement. So you just choose whatever you can go with. You shed this directly or you try simplifying. So question 4, this one, it is exactly the same as like this. So let us shed. So x is this. We can shed x. Yeah, so first let me just start with the other one. So we're going to shed x later. So let us shed y minus z complement. Remember, if you want to shed y minus z, you just shed what is in y. You see like that, this is in y. But we're not shedding anything in z. This is y minus z. Yeah, so but remember, since we have a complement, it simply means we shed outside here. So meaning this is y minus z complement. You shed outside. This is y minus z complement. The whole thing in blue, it is y minus z complement. And then, so I've shaded this. It is the part in blue. And then x intersection, let us shade zx. So this part in blue, we're not interested in it. So the part in blue, it was just y minus z. Oh, sorry, the part in black, it is y minus z. Complement, meaning we shade what's outside. So this is what is outside. So we want to shade zx. So x, we shade it. Yeah, so intersection, meaning where do we have common things. So the common things, it's in here, where we have two colors. So meaning when you simplify your work, so this thing for shading with different colors, is done as rough work. It's like you're solving on a piece of paper. So this is the final answer. Yeah, so this is what you get. So you can do the same here. I think I want to do for you, or maybe let me just quickly. You shade what is in X. Oh, so remember this is X intersection Y minus Z complement. So these are the things in X. And then we shade Y minus Z complement. For you to shade Y minus Z complement, you should know what is Y minus Z. So Y minus Z, the things in Y, but they are not in Z. So meaning it is this area. This is Y, but it is not part of Z. Yeah, so this is Y minus Z. The things which are in Y, but they are not in Z. And then complement, simply meaning we're going to shade outside of this. So this is the complement. Yeah, you go on. So the intersection, it is in here. So meaning this is where your final answer is. Yeah, so remember for this one, shading just takes practice. Like the more you practice, just like that. So this is your exercise 2. So in the previous video I said you're going to have a lot of exercises. So answer question V and question 6 there, 5 and 6. Try shading, show me what you get. So submitting is not mandatory, just if you want to verify. Yeah, so if you're watching any of my videos for the first time, you can just let me know that no, I got your line from a certain video on YouTube. So this is how you can shade. So let's look for something different now. So speaking of something different, this is what I have for you. So is this so clear? So in each of the Venn diagrams, use the set operations union and intersection, also the complement, to describe the shaded regions. So how do you describe this shaded region? So in the previous video I told you, like, you just look for clues, you look for hints. You can see set A is not shaded here, so this is telling you that A, maybe it's a complement. And then you look at B. Okay, B is shaded, but it's not everything which is in B. Yeah, so but B is shaded, so I have A complement and B. So this is the intersection. So this is A complement, what is outside of A, intersection B. Yeah, so you can actually prove this, like yeah, so when you understand maths more, you can be thinking of things in a lot of ways. So like our answer here, it is A complement intersection B. So I just want you to understand how this is the answer. A complement intersection B. What if they give us to shade this? You are going to shade A complement. What is outside of A? You shade it. So all this is A complement. What is outside of A? You shade. Yeah, so this is A complement. Everything outside of A we have shaded. And then B, it's not a complement, meaning we shade inside of B. So this is B inside of B. Yeah, so this is what we have. So for the intersection, it simply means what are the common things. So which area has two colors? You can see it is in here. So here we just have black. It will not be part of the solution, where we just have black. And then also here you can see we only have red, meaning red can be removed in here. So this is the shading: A complement intersection B. Yeah, so this is A complement intersection B. You can even write it like this. Another way of answering, you can see B is shaded, but what is in A is not shaded. So this is just B minus A. So these are two correct answers. Very correct. And then for this one, it's quite similar to this. So the answer for this one is A complement intersection B. For this one, it is A complement union B. So the difference is intersection and union. For the intersection, we just shaded what is in B, like the common things. But union, what is outside, we have shaded outside of A, and everything in B, including this part. You can see here it was not shaded, here it's shaded, and outside it's shaded. Yeah, just like that. And then we come to a more interesting one. How would you describe this? Okay, here I have to think also me. Oh, okay. So like I said, you just look for clues. You just look for clues. You can see this, it's giving you a clue that I think I have A intersection B. At least I have somewhere to start from. This is A intersection B. And then what else can you see? You can see that inside of A it is not shaded, and also inside of B it is not shaded. So meaning everything in A and in B, these things were not shaded, meaning we have our complement. Yeah. So A intersection B, and then so this is the middle part, and then everything in A here and there, things were not shaded, meaning A union B its complement. Yeah, and then we put intersection. Intersection or union. Yeah, so this is why you'll be losing marks a lot. So you can just think like, if I put intersection, would this make sense? So like if we say intersection, it simply means A intersection, this part A intersection B, it is in here, they have shaded, and then A union B, things outside of A and B, things outside of A and B. So you can see the two colors are not meeting, like, so this should not be intersection. We put union to show that we're just combining. So when you say union, I've even explained in the video for set operations where I said union, it simply means to come together. Yeah, I even drew something like this. A man and a woman coming together, they make a union. So union in mathematics, it means and. Yeah, like and, or is it or? So this is the shading which is here. A intersection B, and then we combine it with what is not part of A and B. And then for this one, we actually answered it already. Yeah, so this is C plus B. Yeah, so the things in B and in C and B, except the intersection. I've even showed you the other forms of writing this. Was it in the other video? Yeah, it's in the other video. So this shading, you can also write it as C minus B, because here we have shaded what is in C but not in B. We combine with this is B minus C. So two ways, you write C plus B. So this is the symmetric difference of two sets. I explained this in the Megaminds document. I'll show you, or let me just show you right now. Okay, so just a quick break. This is an example of the Megaminds documents. So I have the symmetric difference. Yeah, so I haven't talked much about this like in videos because it's in form of a document, so you can check this out. How you go about this. What is A plus B? Yeah, so the document contains a lot of other things which can be very helpful. Some exam questions, irrational numbers, how to prove a number is irrational. Yeah, all those things, repeating units, numbers on a number line. Yeah, so that was our quick break. Let's quickly finish this tutorial. So here we've said this is C plus B. I don't know if this is pronounced as plus, but that is my way of saying it. And then the last one we have this. So here you can see everything in A is shaded. So this is giving you a clue that maybe A, we're going to say union A, like that. Everything in A is shaded, and then C and B, so here we have, so this is our C. How would we describe this? One of the ways we can just say, yeah, so like this is our C. So the clue I'm getting here is that you can see the things in C, they are shaded, and then but this part which is having B, it is not shaded. So this is C minus B, and then we combine it with B here, it's shaded, B is shaded, but except the part having C, except the part having C. So what I've shaded there is, or what I've described rather, is looking like this. So C is shaded, but not here in the middle, and then also B is shaded, but not there, and then everything in A is shaded, so you just say union A. So this is how you can answer. So you can simplify and then you get other answers. Yeah, so this is how you go about shading. Yeah, so I hope you found this video helpful. So keep on practicing. Oh, I know I've left this one. I can't solve everything for you guys. So try this and then inbox me on WhatsApp. Like, what do you think about my solution? And then we can discuss it. Yeah, so you can try this one. So we end here. See you in other lessons.